Okay, here's the second part of the base and number systems. This is part 2. We're going to pick it up where we left off with that first video. We were up to base 16, the hexadecimal system, which uses the digits 0 through 9 along with these 6 letters. A represents 10, B 11, and so on all the way through F, which represents the number 15. So let's look at an example of this. Now here's a hexadecimal number. Let's look at this one. 3A 9E. Right, we can say base 16, or let's just put hex down here for hexadecimal. Alright, that means base 16. To convert that back to the decimal system, we still have these place values just like we did with all the other bases. So this is actually, remember your base is 16, so that's 16 to the 0, that position. This one, the 9 is in the 16 to the first. The A is in the 16 squared, yep, and the 3 is in the 16 cubed position. Alright, and remember that A stands for 10 and E stands for 14. Every time I work with the base 16 or hexadecimal system, you'll always see me write these letters out to the side because I can't remember all those numbers, right? I just write down A through F and then put 10 through 15 so that you can reference them pretty quickly. Alright, let's see how this comes out. This should be 3 times, remember my base is 16, that's in the cubed position, 16 cubed, plus my A now is 10 times 16 squared, plus 9 is a 9, times 16 to the first, plus, here's the last one, E represents 14 times 16 to the 0. Alright. So, again, you'll have your calculator. 3 times 16 cubes, kind of a big number. What is this? 12,000, 1228. Whoops. 12,288. How about that? Plus, if you take 10 times 16 squared, you're going to get 2560. Plus 9 times 16 gives you a 144. And plus 14 times 1 is 14. Right, so if you total all that up, you're going to get 15,006. Alright, do not put a base on that, or if you put base 10, it's okay, but, you know, we don't want to write base 10 or decimal right there, because this is already in the decimal system. So, hexadecimal number 3A9E in hexadecimal is equivalent to 15,006 in the decimal system, base 10. Okay, so what we did so far in this part 1, we did all of those other bases. We looked at all the other bases, and then we were converting back to decimal. But let's actually go the other way, and let's convert decimal to these other bases. That's what we're going to do. Alright. Alright, we're converting decimal, which is base 10, to other bases. We just did those main ones. We did, base 2 is binary, we did octal, base 8, we did hexadecimal, which is base 16. Those are the normal ones, but it's the exact same thing if you use your base of 7 or a base of 5. You do it the exact same way. Alright, you could use any number really for your base. Okay, so yeah, let's look at a decimal number. Let's consider the decimal number 275. Oops. Alright, let's take that 275. We're actually going to convert it a couple different ways. For part 1, let's convert to octal to start with. Alright, octal is base 8. Alright, there's a little procedure to follow, and it looks like this. Remember, my number is 275, and what you're going to do, remember that octal uses only digits 0 through 7. So what you're going to do is take this number 275 and we're going to divide out by 8. Now I write it this way. You can write it going up that way, and then you would read your answer off going down, but I like to divide going down this way, and then when I read my answers off, my answers are going to be going up. The way that we're going to get these numbers between 0 and 7 is going to be all of the remainders that are left over when you divide out. Right, so you'll need your calculators, and if you take 275 and divide by 8, the whole number part is 34, and what you have left is, it's 34.375. That 0.375 is the remainder part, and you want to actually figure out what that whole number remainder is. So you can take 0.375 times 8, and that remainder is going to be 3. Another way you can find out the remainder is just take 8 times 34 and then subtract it from the 275. That gives you your remainder out here. Alright, but these over here are your remainders. Alright, that's going to be your answer. All these digits out here are going to be your answers. Alright, your remainders are going to be written right out here. Alright, so all we did was take 275, divide by 8, and the whole number part was 34, but the remainder is the answers that we're looking for. Okay, and then you go again. 8 goes into 34 actually 4 times, and that remainder is going to be 2, because 8 times 4 is 32. When you subtract, that remainder is 2. And you know that you're done when this number down here is less than your base, because you can't divide 8 and 4. Alright, so now make sure whatever that number is left over that's smaller than your base, that's the first part of your answer, and remember to read your answer off going up. So all of these numbers here, which represent those remainders, have to be between 0 and 7, or less than 8, I should say. And since we divided going down, you read your answer off going up. So the answer is 4, 2, 3. This is base 8, or you can put octal down there if you want to. So we just did, we converted from the 275, which was in the decimal system, to octal base 8, which is actually 423 base 8. Don't forget those bases on your answers. If it's something other than base 10, you have to put the base in your answer. Alright, let's do a binary one. Here, that one wasn't very long, because 275 isn't that, it's not that large of a number compared to 8 when you're dividing out by 8. Let me actually start another video for this one. This one's almost 9 minutes, so let's stop here, and then I'm going to continue on with that part 3, and we should finish up with that.